Hey everyone, welcome to the stream. So today's stream is going to be a bit different because I don't actually know what exactly we are going to do today. So yeah, the title says we are going to check the Jack programming language, but that's about it. There's no real objective right now over here. We don't have a specific program that we are going to build in this stream. But we're going to check the Jack programming language. So I think we'll try to run the already existing programs and check how the syntax works and all of that. Let's try to run this hello world program. How do we run it? Write your application if you wish to use use the supply jack compiler to compile the myapp directory. Compiler will translate all the .jack file corresponding .vm files. The compiler complains about error, debug the class. Next, let's go inside this directory hello world. What do we have? We just have a single .jack file. So we'll have to use the compiler to compile this jack to VM file. Let's check the compiler. Where is it? Assembler, CPU, jack compiler. Jack compiler. What the hell? It apparently compiled something, but we don't have anything. We had the .java files, .jack files, not Java. So it might have compiled those files. Did we have any jack files? I don't think so. We didn't have any jack files inside this directory, so I think we are safe. What is inside this folder? OS. Wait. Is this folder? Did this folder got created after we run the jack compiler? If it did, that means we had an OS folder earlier. Let's check the bin folder. Bin contains assembler classes. These are all Java files, so we are not worried about those files. HDL files. We do have this class files, but yeah, they belong to Java. Let's leave it. So how do we compile the hello world program to test the program? Load the my enter. Do I have to provide the directory like this? Let's do something like this. We want to compile, let's see, 09 hello world. Compiling projects. Okay, if it worked, then we might have, yeah, we do have the compile file main.vm. Let's check this file main.vm. Okay, it's just a VM code. So now to run it, let's get the VM emulator. It is inside Nand2Tetris tools. What is it? VM emulator. X9 hello world main.vm. So implementation was found for some function which are called in the yes. Let's try to run it without any animation. Cool. So we did display the hello world. That was not exciting. Let's try to compile a different program this time. What else do we have inside this? We have a bitmap editor, fraction, average, square. Let's compile this square. It doesn't contain VM code, so after we run this, it should contain the VM code. Okay, that was quick. Let's go inside the square directory. We have the VM code. Okay, how do we load all these files? Should we load the folder? Let's see, where is it? Square. Yeah. Let's run it now. Cool, it is running. So we can start it like this. Cool, it's nice. And if we click X, Z, X increases the size, Z decreases it. And we can also quit the program. Okay, now nothing will happen. What is inside this bitmap editor? Let's go inside that directory. Bitmap editor.html.iml. But there's no break. Okay. Bitmap editor.html. How do I use this? What is inside this IML file? I've seen this kind of file for the first time. It's just XML. Awesome. Let's try to open this bitmap editor. Let me get the file. This looks nice. Let's check the source code. Bitmap editor HTML. So apparently it will generate the source code for displaying the sprite which we draw over here. So let's try to draw something. Let's try to create a character like a Mario. Let me search Mario sprite. Let's try to create this kind of character. Let's start from this point. Okay, I don't think we'll be able to fit the whole character. So let's try to reduce it. There should be something which clears all of this. Let me try to modify this HTML file. I want a button which will clear all the values. We have an init function, grade, init grade variable, grade new array. Okay, we can call this init grade function. This will clear out all the or maybe I can just I can just refresh the page. Where did it go? Okay, here it is. Let's try to draw a small version of this sprite. So do we have a black and white sprite? EW sprite. Damn, this looks horrible. Not bad. Not bad, not bad. Good, good, good. Well, it doesn't look that much worse. Let's get rid of this part. It looks a bit like Mario. Let's try to copy this code. Let's see. Let me create a folder named Mario. Yeah. We have to create a main.jet file. What will be inside it? Let's check another program. Square. Inside it we do have a main.check, square game.check, and a square.check. We need to have at least one file named main.check. Check what is it inside. Class main. Alright, let's get a main file first of all. Main.check. Yeah, main.check. Class main function should also be called main, right? This is a constructor function. Function void main. Check. Let's get rid of all of this code. Let's not. What else do we need now? We need to generate this. Let me just copy this line of code from here. And call it from here. What I can do now is do draw. Should I directly call draw? Should I say main.draw? Let's see if this works or not. Draw location. Does this represent location? Location is 16 pos. Let's give memory address is equal to 16384. This is the address of the screen RAM plus location. Let's say we give 10 as the location. Let's try to compile this program and see if this works or not. Do we have to change anything else? I don't think so. Mario. Oops. It's not defined as a field. Yeah. We need to get this. It's not defined as a field. Should I define it like this? Variable field mem address. What else do we need to define? I guess this is it. Do we need to get this memory? Let's try to compile it now. Expected. Where did we miss? Did we miss a bracket somewhere? I don't think so. Why is it giving us an error? Let's check the error message again. Line 3 expected at line 3 over here. Wait, can we not like this, like it like this, where field? Let me check the docs. Nand2Tetris projects 9 OS API. Oh no, this is cryptic. Let me open up the slides. This is how the code looks like. How can we define a field variable? Should it be inside this function main? But then we won't be able to use it over here. Oh wait, what if I cut it from here and paste it here? Will it work then? Let's see. Expected primitive type or class name. Line 8. Okay. Should I give it an int type? I think so. So let's give it a type of int. Oh, we did compile this time. So do we have the VM file now? 609 Mario main.vm. Yeah, let's try to run it. Load program. We need to load Mario my main.vm. Yes, please. Oh, it did display a Mario character. Cool. This looks nice. Great, 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 great. We have a Mario character, guys. Let's see what we should do now. Now that we have a Mario, let's try to move this character. And before we do that, what do we need to do? We need to give it should be grounded, so it should be over here, not at the top. So we probably should give a different location. Let's try to give, which location is this exactly? Let me check the slides. Graphics processing. Where is it? Graphics processing. Strings, arrays. Yeah. Okay, so this is what it looks like. The coordinate system, it starts from here 00x, but in this case we are just providing a single location value. Okay, all right, so this location is inside the memory 16384. If I provide 10, wait, so what if I provide 32? This should, let's see what it happens. Now we need to recompile it. Okay, let's load the program again. main.vm. Yes. Oh, great. So it did start from the next line, but we want to start it at the end of the line. So let's figure out the memory location. 0, 32, 32. What is the last address? I should check. Oh, not virtual machine. Machine language. Yeah. I need to check the screen memory mapping. Registers. Not this. Yes, this one. So it starts from 16384 and it ends at, well, let's say if I provide 32, that means this this row will be affected. From 0 to 31, it is the first row. So when I provided 32 as location size, it started writing from this location, row 32, row 0, row 1, row to 55 to 55 is 8159. But as our sprite is, let's see, it is a 16 by 16 pixels, so we'll have to take care of 16 pixels from the where was it? So it should start at 255 minus 16th row. So how much is 255 minus 16? 55 minus 16, 239. Okay, it should start at 239th row. How do we get the row number? Word is equal to this column okay, let me place this value, was it 239, inside this equation. So 32 into 39 plus column will be 0, so 16384 plus 32 into 239, 239 into 32 plus what was the value, 16384, 16384 24032. Wait, 7648. Yeah, this is the location that we need to edit in this file. So let's write 7648. Let's recompile. Load the program, main.vm. Yes. Awesome, it is at the bottom now. Cool. So now we should try to move this. But before we do that, we need to organize this code. We can't directly write this inside this main class, so we probably need a class called Mario. Yeah, I guess so. Let's get another file. We'll call it mario.vm, not vm.check. This will contain the logic for this character. Class Mario. Let's keep it empty for now because I don't exactly know how to organize. So we'll have to refer the Square program. Let's go inside the directory of Square, which is x09 Square main.check, main.vm, Square check. Let's check square.check. Okay, this is how our Mario file should look like. It should have field variables like this. Okay, so this is how we should initialize a field variable, not with a var keyword, but just with field and then integer x1. Okay, then we need a constructor function and a draw. So this construction function will probably take the location. So let's try to copy the structure of the square. We should get a constructor inside that file. Mario.check. Well, let's just copy it from square, not main.check. We need square.check. Open for reading only. And let's paste it over here. And let's change this name to Mario. And we are not going to provide integer x, ax, ay, a size for now. So let's see, what should we do? Let's get rid of this. We are going to provide only one integer, and it should be the location where we want the Mario character initialized. Okay, let's get a field variable, filled in location. Let's call it lock. Lock the hell? Lock location. What is happening? Location, let local location, return this. All right, and now the draw function that we wrote earlier in the is it indented like this? Okay, so now we need to bring the draw function that we wrote earlier. Let me just copy it from here, and this should probably be a method. So yeah, awesome. Okay, let's see now. We need to use the location. We need to use the location variable. So we don't need this, and we are going to use the lock field. Can we directly use location variable like this? Let me check the slides. This is how we initialize a field variable. How do we use it? We can directly use it inside a method like this. Awesome. So we have got the Mario. What we are doing over here is setting the location when we initialize the Mario object, and we call this draw. This will draw it. So now we need to modify, let's see, which file name. Let's get rid of this, and here we will create an instance of the Mario class. How do we create an instance? Square, square, square game, main. All right. First, we need to get a variable of 5 square, not square, Mario, and let's call it Mario. After that, you can do Mario is equal to Mario dot new. This will call the constructor. Let's give the location. What was the location? 7648. All right. 7648. This is the location that we should give. Now we need to fire this command. Mario. Okay, we start drawing from the constructor only. So I don't think we need to do anything else after we get main.checks. I don't think we need to even call any method. Let's see what happens. This is main.check and this is Mario.check. Let's try to compile it now. Yeah, I figured. So main address is yeah. We haven't declared this main address. Where should we declare it? Well, we are just using it over here, so where name address, this should be int, so okay. Cool, it compiled. Now let's try to load it again. Yeah, this time we need to load the whole folder. Yes. Good. So we have a character now. What else do we need to do? Let's see. We don't have anything inside buffer. Okay. So the square contains two filled variables, not 3 filled variables, int x and y, size, and we have a constructor. To the constructor we provide 3 input, variables arguments, and this will be initialized inside these three variables. After that we call draw, so this will draw the square, the specified x and y coordinate. Cool. And after that we have different methods to change this object. We have dispose, this will clear the memory. We should also write a dispose function. Let's get this dispose method inside this Mario. Was it at the square dot check? Open it for read only. Why is it indented like this? Method void dispose do memory dot deallocate this. Cool. Then we have erases the square from the screen. We also have increase size. We don't need increase and decrease size for Mario character. Yeah, but we do need this navigation method, move up. So let's try to figure out what it does. Let's read this, move left. If x is greater than 1, okay, what is x? The x coordinate. Alright, do screen dot set color false. What does it do? Set color false. So this method clears screen dot set color. I guess it clears the whole screen. And after that do screen dot draw rectangle. Okay, so first we clear the screen, and after that we draw the rectangle again. So how do we draw? Where do we draw? X plus size minus 1. X plus size, y plus size. Right, what are we passing here exactly? We need to move the square to the left. Okay, so where is the size variable? Size, length of the square in pixels. Okay, we have x, y, which are the coordinates, and the size is the length of the square. So suppose if the size is 30, then let's check this draw rectangle. Okay, it's the built-in method. So we'll have to check the API. Screen API. Yeah, this one, screen API, draw rectangle. Yeah, we pass x, y, x. Okay, so this is the first corner, top left corner, and these are the coordinates for the bottom right corner. Here we are giving this. Oh, wait. Okay, so here we are giving x plus size minus 1 as the x coordinate of the top left corner. Why? So we need to move the square to the left. Okay, wait, left, right. So suppose if it was at this point, it should be now at this point. How do we figure out this point based on this point? So this x is the point where it was, plus size. So this, wait, why are we adding this size variable? Let's check move right. Yeah, so the condition here is x plus size should be less than 510 because this is the width of the screen, right? 510. It is 512, I guess. Okay, so x plus size, x is the leftmost position, so we should first do x plus size, which will give us the rightmost position of the x. Okay, it should be less than 520, so it should not go outside the screen. Okay, set color false, draw rectangle, xy. In this case we are providing xy, so as we are moving to the right, xy, x plus 1, y plus size. So I suppose X and Y is the topmost left corner. This is confusing. I need to check it again. Screen location of the square top left corner. Okay, yeah. Okay, so this XY is the screen location. I get it now. Initially it will be 0 0, so it will start at this point. Suppose this is the screen, the square will be at this point. Okay. But when we fire this command, which was move right, what happens is first we clear the screen, then we draw the rectangle again, but this time we are drawing at XY. Shouldn't we change this XY position? Let me check. When we draw it initially, what arguments do we provide? We provide x, y, and x plus size, y plus size. Okay, so this is correct. X plus size, y plus size. Oh yeah, I get it now. This set color false. This will first clear. Okay, first we need to clear this rectangle. So select the rectangle where it was previously. It was at x and y coordinate and x plus 1. Why is it just x plus 1? It is y plus size, but x coordinate is same. Why? All right, I see. We need to just clear a portion of this rectangle, not the whole rectangle. So x plus 1 will be at this point, slightly, just 1 pixel apart. Wait, how is it 1 pixel apart? It is saying that we move right by 2 pixels. Then why are we giving over here x plus 1? So that we change this x, let x is equal to x plus 2, and we draw the new rectangle there. So this is the logic of move right operation. Here we provide x plus size -1, x plus size let me try to do something. Let me comment out this line of code. Now I'm going to try to compile this program. Square. Square. Let's load it. Program square. Yes. Let's run it. Okay, let's see now what happens when I click the right arrow key. Up. Okay, it cleared off this portion. So now we know exactly. Where is it? Now we know exactly what this portion does. It clears off this part. Right. That much we figured. Okay. So now let's comment this line and uncomment this. Let's recompile it again. We need to load it again. Load program square. Yes. Let's click right again. Oh, cool. What actually happened? This is nice. Let's try to analyze what exactly happened here. So when we click this right, when we call this method, which apparently happens when we click the right arrow, it does x is equal to x plus 2, screen dot set color, screen dot draw rectangle. It tries to draw the new rectangle at this position. But as we are not erasing the previous part, that's why we are getting the long streak. Let me try to change the logic of square game. So main, not main dot check. What else do we have? Square game. Keeps on drawing until the end of the screen. if key is equal to, wait, where is that, right 132, it changes the direction variable with 4. And it keeps on moving the square until key equal to not 0. Wow, this is confusing. Let's go back to square. We need to use the same kind of logic for the Mario as well. Switch window. Which windows do we need to switch? Fourth and fifth. This is 4-D, fifth. Non-command. Move window. Do we have a move window? Yeah. Did it work? No, it didn't. Be a good developer and write a command. Draw the Mario character. Let's copy the move right command from square.check. Square.check. Yeah, open for it only. Move right. Oh wait. Of course, this is a Jack language. It doesn't care about the indentation. Not like Python, right? Okay, now we need to modify this. Move right. But now we are not working with the screen API. We are directly working with the memory location. So this is not going to be the same method. But we still need a condition to check if the if the full character is not going outside the screen, or should we? Let's not write the condition right now. But what we do want is to draw this Mario character. So now to move this character to the right, what should we do? Let's see. It should be shifted. Oh, so can we do the shifting inside the memory? So maybe we should change the location somewhere. So what is this doing exactly? First we get the memory address, which is a 16384 plus the location. So this will give us the particular row, right? Revise the memory location again. So what is this exactly? 16-bit values inside of one RAM. 0, 1, 2, 3, 32. So we have a display of 512 by 255. So the first row will map up to 0 to 32 RAM registers, right? So when we do memory.poc memory address plus 0 set 0, this will zero out all of this. Right, this will zero out all of the registers, I think. Let's check the API of memory.poc. Memory.poc sets the RAM value at the given address to the given value. Wait. In this case, we want, how is this going to work? This as per the API. Let me open it up in new file. New. Yeah, so let's see. Right now everything is 0. I select the first value. All right, I get it. So wait, memory address is 16384 plus the location. So when the location is 0, it starts at this point. Okay, I see. It affects the first register only of that particular row. I see. So in this case, location is 0. No, the location is this point, somewhere around this point, that particular row. Right. Yeah, I get it. So suppose if we want to move the character by 2 columns, we should shift the value. All right, we should shift these values. So if we want to move the character by 2 pixels, suppose we are creating a square at this position, starting from this. Let's just take the character. So if we want to shift or move the character 2 pixels to the right, we should shift the values 2 pixels by 2 pixels. Can we change this location? Well, if we change the location, it will just change the row, so it will move up and down. Yeah, we have to change this value somehow to move the character to the right. How can we do that? See, 16384 is the starting address of the screen and location. So this will become the memory address plus 0, memory address plus 32. This is moving down the rows. This is the first row, second row, third row. So yeah, we don't need to change these values. The rows will remain same. But can we affect this? So to move our character, we either have to change these values or this location, this memory address, and we can affect this memory address using the location variable. Okay, let's see. If we were not given this location variable, what would happen? It will start changing the memory address from 16384 plus 0, 16384 plus 32. So it will start from the first row. But when we change the location variable, it changes the row. But how can we change the column then? Wait, can we use this equation again? This will give us the word where that particular pixel specified by row and column resides. This equations will give us 0, 1 up to 8191 from these values. Yeah. Okay, after that, what can we do? Set the column percentage 16, modulo 16th bit of what? 2, 0 and 1. Wait, do we have any other programs? Any graphical programs? Projects. We have average, hello world, fractionist, Mario. Nope, we are not given any other graphical program. That's just it. So we'll have to figure out logic by ourselves. How do we move it to the right? How do we move this character? Where is it? Where did it go? First compile the program. It's Mario. Yeah, so we have the character, but now we want to move it to the right. We need to figure out a way to move it to the right. What can we use? Well, for drawing, we are using these statements, but these statements don't really give us the wait. We are given a 16 by 16 pixel map, and we are affecting it inside the screen using this instructions. What this instruction does: poke, moving it by 2 pixels will be a bit complicated. Do we have the source code for the screen? Let's check. Into Tetris. Well, let's go inside tools. Do we have anything over here? We have got the source code, but it is in the form of VM. Do we have it in the form of .jack files? Jar files? I don't think so. We don't have .jack files. We have the OS files in the form of .vm. Let's try to find the source code. It was written somewhere that, where was it? 2jack OS implementation. One OS implementation was written by Yaron in Jack language and was then translated using a Jack compiler into VM. Okay, so it seems we don't have .jack implementation of the OS. We have .java implementation and .vm implementation, the compiled version. Why wouldn't they give us? Yeah, wait. Here's the Jack OS API. We don't need. Let's see if this guy has GitHub profile or not. Maybe we can find the source code in his GitHub profile. No, doesn't seem to have a GitHub. Try to stalk him on Google. Senior software engineer. Yeah. So does he have a GitHub profile? This is his LinkedIn. Let me try to find Nand2Tetris OS. Jack OS files. This is the memory version. We want the screen version. Nand2Tetris OS project. No, this is not what we want. Let's check out this guy's repository. Scilab. What's that? Forget about it. What happens if I increase the location by 1 and call the draw again? Let's see what happens. Where I have to use let lock equal to lock. So I need to figure out even if we can do this or not. Let's assume we can do that. Before we do that, let me comment out this lines of code. Okay, now why is this indentation map messed up? Okay, let's see. Let's call do draw again after we change the location. Do we need to have a return variable, return statement inside this? I think so. Return. Okay, let's see what happens now. But wait, we still need to call this move right function. Wait, we had a memory function system. Wait, yeah, let's try to use it for testing. The draw. Oops, the heck, this is messed up here. Okay, let's see, let's use this dot wait and milliseconds, 1000 milliseconds is equal to 1 second, right? Let's wait for 3 milliseconds. I guess I have to write do first. Let's call do move right after. Let's try to compile this program. Thankfully it did compile, so let's load it again. Mario, yep. Oh, disappeared. Why did it disappear? What happened? When we called move right, what exactly happened? Why did it disappear like that? Let's check the memory. 16384. Where are all the values? Nothing. It's apparently empty. So what happened when we call location is equal to location plus 1 do true? First of all, can we even do this? Let's check the docs. Location is equal to location plus 1. This is assignment. Oh yeah, so it did work. So after 3 seconds almost, 3 seconds, right? Okay, so we needed to do this. We needed braces. What really happened is after 3 seconds it moved to the right, but when we move to the right we need to clear the screen as well. Now we have 2 copies of Mario. That's not exactly what we want, but it works, I guess. So now let's try to write a class where we can move this Mario function. Let's use this do screen dot clear screen, so that way the previously displayed character will be removed before we create a new Mario. Yes. Awesome. So after 3 seconds it moved to the right, but now we have to write a logic so that it doesn't move after 3 seconds, but it moves when we click the right button. This is not exactly what we want, but it works because I can't figure out a way to move it by certain pixels. I can move it by 16 pixels only apparently. And if I want to move it by, let's say, 2 pixels to the right, in that case it will involve a lot of this manipulation of these values, because I might have to shift the values, binary representation of these values by 2 pixels. Wait, maybe not. So suppose I divide all of these values by, okay, so I have this idea. Let me try to check if this works or not. Should I give a variable? Okay, let's do it. Int position. So suppose I use it like this. I think it will work. Let's just remove it. This works for now. Let's take the square program. How do we control the movement? This is just yeah, we control it from the square game, I guess. Square game, square game direction. Move square, run. Okay, so we need something like this. Let's get this. We need a class name. Okay, let's call it game.check. No, not this. Check. Let's copy the code from square game dot check. The name should be game. Square instead of square, it should be Mario. And this should be Mario as well. Constructor game new. When we call this constructor, what should happen? See, we should get a Mario. Mario new. What do we need to pass? The location probably. Let me check. Mario.check. Is it open somewhere? Mario. Yeah, so to the constructor we need to pass the location. The location was with 7648. Seven six four eight. Direction, let's just keep it for now. Dispose square. Instead of square we should dispose the Mario. Move square. Instead of move square it should be move Mario. Just square, replace square with Mario. No trading characters. What happened? Yeah. That void run character key, the key currently pressed by the user, boolean exit equal to false. While not exit, keep on running and check the key. Wait, the key is not initialized to 0, but we are checking it over here. Okay, while key is equal to 0, let key is equal to key pressed, do square move. So instead of move square, this should be move Mario. If key is equal to 81, let exit equal to true. Increase, decrease, we don't care about increasing or decreasing, so let's comment it out. And for now, yeah, so when the right arrow is pressed, direction should be 4. Waits for the key to be released. Inside move Mario, we will call move Mario right. let's open up Mario.check. Here we do have move right. But now yeah, well, instead of wetting it over here, we can remove this and move this. Don't need to call it from here, so let's remove this as well. But we do need to clear the screen somewhere, and we'll do it over here before we draw it again. Let's try to compile this program. Of course it didn't work, doesn't exist. Yeah, all right, I know they don't exist, so let's comment them for now. Game.check. All right, hope this works. Okay, did compile. Load Mario. Yes. Run it. What? Let's try to press right arrow key. Oops, nothing happened. Why? Nothing is happening. That means there is a bug in this run function. Wait, but where are we calling this run function anyway? Yeah, so that's the problem. We are not even calling this run, and we are not even creating the instance of this game. So let's fix it. Need to go inside emain, and now instead of getting the Mario, we should get an instance of game, not ham, game. Dot Mario game dot new. We need to provide anything. Game dot check. Let's check the constructor. No, we don't need to provide any argument. Name. So let's remove this. Okay, let's try to compile it now. Good, it did compile. We need to load it again. Mario. Load the program. Yes. Run it. Let's see what happens when we press right arrow key. Oops, nothing seems to be happening. Why is nothing happening? And we are creating an instance of game, right? Let's check the game now. When we create a new instance, we create a new instance of Mario as well. We set the direction to 0. Return this. Now, oh yeah. We need to call this run as well. Do game dot run. Do we need to provide any argument? No. Let's compile it again. Let's load it again. Now, when I click the right arrow key, oops, a built-in function tried to. Yeah, I see what happened. Okay, it kept on running. You don't want to do that. You don't want it to keep on running. You want it to move on the right just once. So we need to change something. Try to analyze the logic. This is correct. While not exit. These two while loops are problematic. What the heck is happening? While key is equal to 0. Well, initially it is 0, so it won't ever get out of this loop. When it is 0, oh yeah, we change it over here. So when we press something, it will come out of this loop and it will go over here. And if the key is this 132, let direction is equal to 4. It will change the variable direction. To copy it and paste it over here. Not again. I hate the indentation part. Let me comment out this lines. See what happens. Mario, load the program, run it. Oh, it still keeps on running. Yeah, I see why. See, because we are not changing the value. We are inside an infinite loop until we press a Q key, wait key. It will keep on moving, but that's not what we want. We want it to move just once. See, the key pressed will give us the value of the key which is pressed. This loop will run on infinitely. Yeah, let's get rid of this while loop as well. So this statement, let's change the value of direction again. So let direction equal to 0. Let's compile it. Load Mario. So let's see. It's not even moving now. Why is this happening now? Currently, the character is not even moving. So we are inside this loop, which is waiting for key to be pressed. Oh yeah, I see. We are not getting the key variable. I forgot about it. So yeah, let's write it over here. Let's compile it again. Stop. Let's see now. Good. Oh, there's something wrong happening. When I click once, what happened? Why did it jump that much farther? Is it messing it up? Let me restart it again. reset, run. When I press it once, it jumps off like three tries 3 or 4 times. Why? This is buggy. I'm trying to upload all the files of this project. I'm thinking, should I upload all the files or should I leave out all the compare files? Because those don't seem to be necessary. Only .html files are necessary. But I don't want to go through the trouble of picking out the different files. Let's leave it like this for now. Let's not upload all the files. I have already uploaded hack assembler and translator, so that will be all right, I think. Let me remove all other directories. Oh, what the I removed the directive from. Oh, thank God I had the copy in this folder, or else I would have lost all my files. And why did I fire this command? Let me move all of this directories up. Okay. The hell. Thank God I got all the folders. I almost lost all the project files. Alright, let's go back to project. So, what is happening? The character is jumping too far off. So we need to debug it. Why is it jumping like that? Let's see what is happening. This loop is running, right? While the exit key is not pressed, it will run on infinitely. And while it is running, it will take whatever key we press. And it will store it inside this key variable. And if this key variable, it will change the direction based on this condition. I see. So suppose when I press the key, the loop runs faster than when I'm pressing the key. So that's why it is jumping too far off. So what should we do then? Well, yeah, we are waiting for 5 minutes over here. Then still let me increase this to 10. This is a millisecond, so let me wait for like say 500 millisecond, which will be like half second. Let me compile it again and run it. Load, yes. Let's see what happens. It's not even moving now. Oh yeah, it is moving. I see what is happening. Check this sys.wait duration milliseconds. 500 milliseconds, that means half a second. It will wait for half second, then it will return back and get the key again. Yo, this is not responsive. So it was 50 before, right? Or was it 5? Let's skip 50 and compile it again. Yep. Let's see now. Oh, cool. But sometimes it jumps off twice. So we should have like 100 maybe. Okay, let's stop it and load the program again. Mario. Yep. It seems responsive now. Awesome. Okay. It is working quite up to our satisfaction. So let's now move left as well. But wait, it's a Mario. It's Mario. Mario doesn't move left. It only moves on the right. Wait, it doesn't even move right. Just jumps up and down. What the hell? Oh wait, no. It does move left and right. I totally forgot how this game is played. The screen keeps on moving. We can jump. Let me watch a walkthrough. I totally forgot how it looked. Mario game. Oh yeah, the screen doesn't move. We have to move. But we can't go back. Yeah, I remember now. Once we have gone forward, we can't move back. Cool. So let's try to write the function for moving left as well. So where can we do that? Let's save this and open the Mario Jack. We'll have to write a method for moving to the left. So let's copy this. Yeah, before we move, let me change this command. Moves the Mario, not the Mario. Moves Mario right by, well, not by 16 pixels. Moves Mario left by 16 pixels. The function method will be move left. What should we do over here? Location -1. Oh wait, so now we have to provide the conditions as well. If what conditions should we provide? It should not go outside the screen, so screen location should be 16384. Let me check the slides. 16384 plus 8191. It should be between this. if let's see, location will be between 0 and 8191, right? So location it should be the rightmost location. It should be, this is the row number 255. Let me think. The value of location which we are getting is 67648. So 7648 is the row number. 7648 plus 32. 7648 plus 32. That means the new row will start. Seven, six, four, eight. What will be the boundary? What will be the outermost boundary of the screen? Let's see. This is 512 by 256 pixels. So our characters should not go outside this boundary. Now the memory map is like this. The first row will be mapped to 32 words. So 0 to 32, then next 32 words, and so on. And we are starting from 76, which is the location, 67648. We are starting from 7648 memory address. Yep, it is 7648 the memory address, and we are adding 1 and 1 and 1. But it should go up to 7648 plus 32. 7648 plus 32. The result will be the new row, but we don't want to go up to that row, so it should be 7648 how about 31? Seven, 6, 4, 8 plus 31 is equal to 7, 6, 7, 9. So if location is less than 7, 6, 4, 9, in this case we should move the character, or else don't. Let's compile this program and see if it works or not. pilot. Whoa, what happened? It's not even moving. What did I change? Ah, yeah. If location is less than 7649. Wait, it is going to be less than 7649. Then why is it not moving? Seven six four nine. We are providing 7648 initially. Ah, wait, maybe this is the incorrect syntax. Let me check. How can we use if? This is while. Where is if condition? Classes, syntax, data types, classes, methods. Don't we have if else? Yeah, we do have if else, but what does it look like? The if else statement. Oh yeah, this is how it looks like. If, well, it seems our implementation is correct. Oh wait, maybe I should use it like this. It might work this time. Stop it, Mario. Load the program. Yes. Let's run it now. What? Not moving this time as well. Oh, hey Nivedita, welcome to the stream. Now you can provide the link to your GitHub code. I will check it live. I think you forgot to copy the link in the comment section. Yeah, it's all right. Did you try to run my code? I have provided these two files, hackassembler and VM translator, inside the repository. You probably want to open this one, hackassembler. This one is for VM translator, which will be in the part 2 section of the Nand2Tetris. Oh, there were errors. Can you say what kind of errors did you get? So let me show you how to use this. First of all, let me open it up. Yeah, this will work in any IDE actually, but the only thing is, let's see, you have to pass the file name. File name is the argument. So let me show you how to use this. So yeah, maybe that's why you might not be providing the file name as the argument. So that's why it must be giving you error. Zero, 1, 6. So these are all the files, right? ls add.asm. So if you want the binary file of this .assembly, this is how you should run it. Or I'm just trying to show you how it actually works. So first I write hackassembler.py and I have to provide the file path. There's no link. You didn't send the link. Send me the link again. I can't see where it is. So this is how my program works. When I try to run it like this, I have to provide the ASM file, and after that when I run it, this will give me the output inside this directory add. So now I have this hack file as the output. This will contain the binary output like this. So maybe try to provide your link so that I can see how we can edit your program to work like mine. I don't have the wing ID, or else I will show you how to do it inside the wing ID. Let me check it out. How to provide Okay, let me try to install this wing ID. Maybe I will try to show you how to run my file inside this ID. Okay, it seems that it was installed. Okay, I want to open up a file. Nand2Tetris projects. Yeah, I will provide it right now. Here you go. This is the link to my GitHub account and straight to the Nand2Tetris folder. So, let's try to open hackassembler.py. This is the one you are using, right? This is the same ID, right? Yeah, all right. Let's see, where can we provide the arguments? So this must be what you are getting as an error, because you have to provide the argument. Let me see, where can we provide the argument? Start style. Let me try to Google it out. How to provide online argument in ring ID. Wait, let me see. It might be getting deleted, so let me check. It was not even visible in the comment section as well. Are you sure you are copying and pasting it? Just write the username of your GitHub profile. I will search it. Command line option. The following option may be specified anywhere on the command line. Yeah, so provide me the username of your profile. Is it just Nivedita Sharma or is it something else? Okay, that will work. Let me try to find it. Alright, I have found your repository. I will check it out later, but first let's try to run this program. This is not the path. Where can we provide it? Stack Python cell. So Python cell documentation starts. Preferences. test arguments, the output should be most common use of file is to set the command line arguments. Okay, where is it? File properties dialog is accessed from current file properties. The environment and debug project access from project file properties. All stack exception Python cell stack data tools. Where is it? File properties are used to configure the command line arguments sent to a file when it is executed or debugged. Optionally, to override the file properties dialog is accessed from the current file properties item in the source menu. Properties, environment, file, run arguments. Yes. Okay, let's see. Add /add .asm. So you see, now it ran. Let me show you. Let me first try to delete the file. Nand2Tetris projects 6. So right now these 3 files are inside this add directory. .asm, which is the assembly file, .compare and .hack. This is the output file that we want, but this is from the previous execution. So let me remove it right now. Add .hack. So now we only have these 2 files. Now if I try to run this program, we should have the 3rd file as well inside. And see, we are getting the output now. So what you have to do is you have to provide the path to the file, the assembly file for which you want the binary output, and you have to provide the path in this editor debug section and the run arguments. So maybe try to do that, then it will work for you as well. You just have to provide the path to the assembly file inside this debug window. So try to do that. And so let me know if that works or not. And meanwhile, let me try to check your code as well. Symbol table R0, R4. Okay, why do you have up to R4 only? We have, I think we have in total 15 or 14 variables. Let me check, I forgot. Make a singular pi. Yeah, total we have 15 registers, R0 to R15, so you should probably add those as well, R0 up to R15. Oh, okay. So this is the main function. What are you doing here? Getting a list, create an empty list which will contain. By the way, you won't find any comments in my code. I'm sorry about that. File name. Okay, so in your case you are hard coding. So this is the starting syntax that we have to use in order to complete. Okay, so you are already given the starter code and you have to create your own. Yeah, sure. So well, in that case, so is this the code they provided or did you add something as well? Is this the whole of it? Like, is this the whole starter code or did you add your own code as well? So you have hard coded the value for the file. Okay. By the way, all right. So inside this, you will have to provide the path according to the Windows environment. Okay. So if this is the path to your assembly file, you have to provide that path over here. And I guess you probably have to remove this two slashes. There should be only one slash, I think. So this is what you should provide as the input in your case. So if you provide this path and then try to run the program, you will get the output inside this desktop folder. Yeah, let me see. So first you are providing the file name, the whole path, then you are providing the output file name. Yeah, I'm trying to figure out how to embed my code inside your code. So let's see. File name plus dot hack. In file open file name for reading, print file open, except print open. Open the output file in write mode. File opened, except okay. In file dot read line. So you're trying to read it. After that, while line not equal to empty, get pure code. Okay. By the way, did you try to run my code inside the Wing ID? Did it work for you? While line not equal to empty line equal to get pure code line. If line not equal to empty code dot append line. Yes, and code is the list, I guess. Okay, carry on. Line equal to in file read line, keep printing and reading the next line until the line is equal to null. In file dot close. After that, close the file. After you are done reading, call the first pass and the code, and after that print symbol table. Second pass output file dot close symbol table. Okay, so this function just prints the symbol table values. This is, I guess, the main logic. Get pure code line, find and remove comments and spaces. So line dot index, great. Alright, so now that it is running successfully for you, yeah, welcome. Get your code, find and remove and comment position line dot index. Okay, you are getting the position of the comments if it is exist, and you are removing the comments. After that, you are stripping the trailing spaces. Okay, line replace space with no space. Replace the tab with nothing. Okay, during the first pass, global symbol table I equal to 0, I length code is then. Okay, let's check if this list item is a label symbol. So if it starts with a rounded bracket, that means it's a label. In that case, what we will do, we call this pass label with the code, and if the label not equal to empty, then symbol table. Okay, you add the symbol for that to the symbolic table. But won't this I include the line number of that particular label as well? So what you're doing here is I starts from 0 and length of code. So wait, before you call the first pass, you are calling get pure code. Okay, after that only you are appending. So will this code contain the empty lines as well? Because it seems that you're just removing the comments, but in case of suppose if it is just an empty line, you are not removing that, right? That means this line numbers won't be accurate, or maybe let me check. Dot pop. Yeah, sure. or come incrementing I since we have deleted. By the way, I will be back in a minute. Wait for me. The keys. Oh, hey Jen Pong Thong. You didn't implement the keys yet, but I will. Okay. Yeah, I will check it out later on. Right now, I'm testing this code. Second pass. Yeah, I said I'm already checking out this code right now. So we'll try to play with your code later on. Is it alright for you? Cool. Okay, so ignore incrementing I since we have deleted. So, by the way, Nivedita, is it working? Like, is it giving any output right now? Can I try to test it on my local environment? Will it give any output if I try to test it? Well, it's the code for the, what was it? Hack assembler language. So what it does, it basically gets the assembly language as the input and gives us the binary output. And this is specific to the Nand2Tetris course. No, I wasn't talking to you. I was talking. No, 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 no. It's not get hex to binary. It is assembly code to binary. Remember I talked to you about the Nand2Tetris course? Yeah. So this code is written by a girl who reached out to me. No, it's alright. So this code is written by a girl who reached out to me through YouTube. So I'm trying to check it out. Yeah, assembly to binary. And this is not just any assembly, it is specific to Nand2Tetris course. Hey Nivedita, are you still there? All right. Okay, so Nivedita, I'm going to run this code on my local machine. See if it works or not. Let me download it over here only. I don't know. Let me check. Well, my internet connection seems alright. Maybe it's your internet connection. Try to test your internet connection and let me know. Nivedita, is my stream alright or is it lagging? Oh, cool. So then it must be the internet connection of that guy. Alright, project 6. The code is all Python 3, right? Yeah, alright. Hey Janpon, you should also do this course, man. It will be awesome. Yeah, I checked actually. The stream manager is showing me that it is correct. My the connection status is excellent for me. I don't need to check it out because the stream manager shows that the connection is excellent. But let me check it out anyway. I should pass the file path. Yeah, it is stable for me. I'm getting 5000 kbps connection speed, so it is all right. It must be your internet connection. And